Hello, everyone. My name is Saratz. I'm a senior solution architect here at Flowable. And today I will talk to you about low-code integration with data objects in Flowable Work. I am jumping in today for Valentin Zickner, since unfortunately he is not feeling well today. So let's jump right in. If you have any questions during this presentation, you can always enter them in the field below the video, and then we'll have a 10-minute block after the presentation where you can address your questions. So let's have a look at the table of contents. We'll first look at different integration patterns that we have available in Flowable Work. Then we'll dive into HTTP and REST with Flowable and data objects. And in the end, I will show you a demo, which will be the biggest part of this presentation. In Flowable Work, we have a lot of different ways how you can integrate other systems. The most common way is using HTTP. So you connect to other systems by sending HTTP requests. You can use REST for this. You can use SOAP, GraphQL, and so on. These, as known, is synchronous. So you get an immediate response from the other system. For that, you need to know the other endpoints. And you'll have the status code of the response where you can react on it to, for example, use it for error handling. Another integration pattern is events, which is asynchronous. You have, for example, systems like Kafka, RabbitMQ, SQS, or ActiveMQ, where you send events and receive events. This is completely asynchronous, and you can have unknown event consumers and producers with whom you interact in this way. Another pattern is the external worker. The external worker works rather in a pull way than a push way through REST. So that means that you can have an external system that connects to Flowable and asks Flowable if there is some work to be done. That means that the customer needs to know the API, but a huge advantage here is that it's completely technology agnostic. So you can use basically any programming language that you want or any system that you want. You just need to use the REST APIs of Flowable and then do the work somewhere else. You can also use email for communications, so you can send and receive emails. The email integration works based on the event. So whenever you receive an event, receive an email, an event is triggered, and you can also send emails through that. And last but not least, since we can also do custom applications within Flowable or the pro code integrations, you can write your own Java code and do whatever you want within that. So let's dive into REST. We have different ways of integrating with REST services. So you can see these three bears. The first bear is they are very, very close together. Then we have the bears in the middle. These are a little bit more apart. And then the last bears, they are very separate, which means that they are not coupled that much anymore. So let's have a look exactly what that means. With the lowest level integration, you can use the HTTP task to integrate with another system. That means you drag in this task into your process or case model, and then you define exactly what kind of request you want to send. You define the request method, here the post, you can add additional headers, you define your request URL. For example, here we get the environment property auth2.token URL, and you define a particular request body and store the response of that REST service in the auth token. For basic integrations, that is possible to do, but of course, the disadvantage is that you have to do this for every time you want to integrate with the other system. So if you have another task that does basically the same thing, you have to redo all this configuration. For that, we implemented an additional abstraction layer on top of the HTTP task, which is the service registry. In the service registry, you can define your service model, and in there you can define your base URL, you can define your headers and your operations. And then within your process model, you can just reuse those service models. So in here, you can see we have this close opportunity service registry task, which connects to the opportunity one service, uses the opportunity one operation, and sends in the opportunity ID via the input parameters. Now, sometimes we don't want to interact with these services all the time. So we want to add another abstraction layer on top of that. For that, we introduced data objects in Flowable Work. With data objects, you can define your structure of your data that is stored in a different system. And you can interact with it as if it were in Flowable. So you can, for example, define your different fields here. For the account, we have now here we have the account ID, we have the name, we have the revenue, and we have the account category code that we have defined for this data object. Every data object is connected to a data source. Some might already have had some experience with database data objects, which could also be done here. But we are now doing REST today. That means we have a REST data source that connects to a different system. The REST data source is defined also in a service registry model where we can execute different operations. We have operations for lookup, create, update, delete, and find all or search, where we can retrieve and interact with those data objects. So we have these two integration patterns that are based on top of each other. So let's dive into the data objects. If you have a normal variable in Flowable, in the database, and you, for example, execute an expression $curly brace membership type, then what it does is it retrieves this value from the database. So it does an SQL query in the database and retrieves the membership type in the scope of this process or case and returns you the value. Now we want to do the same thing with the REST data object. For the expression, there is not much a change. You can still do $curly brace account.revenue. And because account is a data object, as you can see here in the type of the data object, our system will automatically know that this data is not stored in Flowable directly, but within an external system that can be connected to with REST. So when you execute this expression, account.revenue, what Flowable does in the backend is it sends a request according to the defined operation to this REST API, retrieves the data, extracts your variable that you want to use, for example, here revenue, and gives you back the value. That means that the modeler doesn't need to know that it's a data object. They can just interact with it as if it was stored in Flowable directly. So let's have a look at the demo. Let's imagine we have a gym, and this gym manages memberships. We have members. These members have gym cards, and when they enter the gym, there's a card scanner where they put their card, and then the card scanner sends a message to Flowable Work via Kafka, and then Flowable Work handles this event. For example, you can scan your card. There's an event going to Kafka that this and this customer is at the gate, and Flowable Work will then tell the gate whether it can open or not. At the same time, Flowable Work is connecting here in our demo to Microsoft Dynamics, which is used here as a CRM system, and is creating and updating customer data directly in Microsoft Dynamics via REST data objects. Of course, you can also attach other potential consumers to our Kafka topic if you want to do some analytics of the customers or entries and so on. So let's have a look at our app. I'm opening up this digital fitness center that we've created for this demo. In here, we have one main case, the customer case, that we'll now have a closer look on. This customer, when the case is created, has a process that sets up the membership. We'll go into this right after it. And we have two stages where we can manage active members and inactive members in our system. In the active member stage, we are listening to card scan events where we trigger a process that checks the membership. And we have some additional functionality where we can change the membership type and we can charge a monthly fee. We can send them some offers with timer events and so on. We can also deactivate the membership, which will change the status of the case. We will go into the inactive member case stage where we also listen to the fitness card scan, but will reject the entry to the customer. So when we create a customer, we have the setup membership process that is triggered. This process looks like this. We have a user task in the beginning where we ask our gym employee a few easy information in a form. So for example, here we ask the first name, last name, the membership type, and if the type is prepaid, we can also enter an amount of visits that the customer can enter the gym. After that, we have an exclusive gateway where, depending on the membership type, we have different actions that we take. If the customer is a flat rate customer, we just create the customer. And if it's a prepaid customer, we create a customer and an opportunity. Now, these tasks here, they are data object create tasks, as you can see up here. So what they'll do is they will create a new data object in our external system, so here in Microsoft Dynamics, and they will store the data object in a variable in Flowable. So here you can see we have this output variable for the create customer task, which will store the data object in the account variable. We're doing the same for the create customer down here and for the create opportunity, which will store in the opportunity variable. This data object create task has some configuration. So first we need to reference our data object. Here we have the account data object that we're referencing, and we have some configuration on how we are mapping data from our process to the data object. In our operation, in our operation configuration, we tell Flowable that we want to create a new data object, and we want to map the first name and the last name from our root case into the name field of the data object. We also want to set the revenue to 5,999 because this customer ordered a flat rate. So let's try this. Let's try this in Flowable Work. So I'll create a new customer. And I'll create a new customer ID. Sorry, C10. And I'm entering now first name, last name, and membership type. So let's say we have a membership called Gloria Day. And she bought a flat rate subscription. So we complete this. And now what Flowable did in the backend is it created this data object and stored it in the case. If we open Flowable Inspect, you can see we have the account data object down here, and it says this is a Flowable data object. And we have the opportunity data object, which was not created in this case because we have a flat rate customer in here. If we go to Microsoft Dynamics now and refresh the page of our accounts, we have a new account, Gloria Day, and the revenue is already set to 5,999. So what Flowable did is it created this data object. It sent a request to Microsoft Dynamics, which was defined in the service registry operation, and created a data object that now is referencing this account. So we can always access it directly. In Flowable Work, if we now open the work form, you can see the information here, the first name, the last name that we've stored. But this information is not stored in Flowable anymore, but stored in the external system. Now, let's have a look. If we create a prepaid customer, we have a different thing. We create a customer and we create an opportunity. So let's do that. So we have a customer, Mike Rogers. We give him a prepaid membership and they have 2 visits that they can go in for the moment. Now the same thing has happened. We have 2 data objects that have been created. We have the account data object, and because this is a prepaid membership, we have also an opportunity in Microsoft Dynamics, which we can have a look at right now. So let's go back to the accounts, and we should now have an account called Mike Rogers. Here it is, with an opportunity to upgrade the customer to a flat rate customer. Exactly. So now this customer is at the gate and has 2 visits that they can enter into the gym. So for that, we have an application that represents the scanning of the card. This application sends an event to a Kafka topic, and on that, the Flowable Work is listening. So let's send an event. Our customer has card 11 and is at card 8, gate 1. So we'll send an event. And this should now have triggered here. Oh, no, sorry. Because the customer already has 2, he went in once, and now they only have one visit left. Let's do it again. And if we refresh the case again, we can see that now they have no visits left, and the next time we have to process their entry. Now, these decrease of the visits, we can have a look at why this happened. We have our fitness card scan event, which is also listening to our Kafka topic. And we check the membership in here. So if it's a flat rate, we just finish the process and open the gate. And if it's not a flat rate, we check if the customer has a prepaid. That means if their number of visits is larger than 1, and we can reduce the visit allowance by 1, which happened the 2 times where the customer entered the gym. Now, the customer now has 0 number of visits. So the next time we access the system, our exclusive gate will not go up here, but it will go down here, and there will be a task where we have to decide what we want to do with our customer at the gate, because they have not a valid entry ticket anymore. So if we decide to upgrade the membership, we'll update the account and close the opportunity in Dynamics. And if we don't upgrade the membership, we'll send the gate an error and the customer is not allowed to enter. Now, if we update the account, we can just update the revenue on the account variable in the root scope to 5,999. You remember, this account variable is a data object, and the revenue is a field in this data object. So we can just write to this field as if it were a local variable, and the data is automatically updated in Microsoft Dynamics. We also update the membership type so that we know that now this customer has a flat rate. If there is an opportunity in Microsoft Dynamics, we can also close that opportunity so we don't have any leftovers in there. So let's try this in Work. Let's trigger the card reader again for this customer. And we go to open tasks. We have the task customer at gate. Now, the customer has the membership type prepaid, but they don't have any entries left. So we need to deal with them. I'm claiming this task. And now I can decide if I want to upgrade the membership or abort the transaction. Of course, we have a very happy customer and they want to upgrade their membership, so we upgrade it. Now, in here in design, we have now with this initial variables task, we have upgraded the revenue. And if we go back to Dynamics, here to Mike Rogers, our customer, and we refresh the page, you can see that the revenue was automatically updated. And we didn't have to define an HTTP task to update this. We didn't have to execute a service registry task. This was all done because we updated the value of revenue in the data object. Now we can do this with all the different fields of the data object. We can do read, we can do updates, we can delete, we could theoretically delete the customer again. So there's a lot of different ways we can interact with that data object. Exactly. So in the data object, let's have a look at the data object itself. The setup membership. In the data object configuration in the account, we have the different fields of this data object that we can interact. Here you can see the revenue that we've changed. And down here we have the data source of this particular data object. You can see this is a REST data object for the account service that is used. If we go into the account service, we have the service configuration. The service type is REST. And you can also see here that is linked to the account data object. In here, we have the different configurations for REST. So we have here, we have the base URL. You could also have this do this configurable through a configuration property. You can have authorization configuration. You can configure basic authorization. You can configure a bearer token, or you can also do your custom authentication here with your custom header that you're configuring here. Now, in our case, we are integrating with Microsoft Dynamics with OAuth. Now you're thinking, okay, but where does this OAuth come from? For this, we have request and response handlers, which will be a new features in Flowable 3.13, where we can define a script which will interact with the request before it's sent and or received. So in here, we have defined a Groovy script that retrieves some configuration properties here. So we have an environment property we have all the different environment properties that we need for OAuth 2, like client ID, client secret, grant type, and scope. We create a REST template and send this to the token URL with all these different properties. And in the response that we get, we receive an access token, which we're injecting to our HTTP request in the authorization bearer token. So let's recap. Every time this request is sent, before the actual request to Microsoft Dynamics is sent, this script is executed. The script takes the properties from your application properties file or any other externalized configuration in your Spring application, sends a request to our IDP to receive our OAuth 2 token and injects it to our Dynamics request before it is sent. So the whole authentication is handled in here. You don't have to write any line of Java. You can just do it directly in here. Of course, if you want to do it in Java, you can do that as well. You could here change it to bearer and here use some backend expression where you have a bean that generates your bearer token. So you could have a token service dot generate OAuth token. For example, you'd have to implement that as a bean, and that will inject this token directly into the call. Exactly. Now, in our operations here, we have the lookup operation where we can find data objects. So if we know the account ID, we can also retrieve a data object without creating it ourselves. This will also create a data object in a variable in Flowable Work. So afterwards, there is no difference if we have created it or if it was created before and we're just referencing it. Next to that, we have the create operation, which we used. This operation calls the accounts endpoint. We have some input configuration here. We have some output configuration because the ID here is stored in the OData entity ID property in the response. And we have some additional response handlers. Now in here, we are doing some fancy operations with the response. We're retrieving the OData entity ID. We do some changes here and put the field back with some regex information, with some regex operations so that we can read it out properly. In here, you can do basically whatever you want. You can have your own Groovy script. You could theoretically also change it to JavaScript, or if you have your own script engine configured, you could also change it to your own custom script implementation. You can do this for requests and for responses. So either before you're sending out the request or after you're sending out the request. Exactly. Okay. I would say that's it for my demonstration. So let's go to our questions.
Okay, we have a lot of questions here, many great ones. Let's maybe start with the first one. Service registry tasks are great. Are there any plans to make service registry calls available from within a form control, not just the workflow canvas backend? I think this refers to the fact that you're mainly using tasks right now, which is the primary way to interact with this.
Yes, you can already execute service registry operations via REST. If you have a form, we already have some components in our forms, so you can for example have a data object table, or you can have a data object dropdown where you can show options from a data object. These already executes operations via REST. So there is an endpoint that you can execute that executes this service registry operation. In that case, it would retrieve the information from the external service. Now, in our case, if we have a data object, you don't need that, because every time your data is provided to the front end, the backend resolves the data object, retrieves the data from the external REST service, and injects it into the form payload. So you don't need to call your external service. It was all done automatically by Flowable and provided to the form before it's even loaded.
Good, I think that answers this question. Then the next one, I think this is a quite simple one. Is the storage of data objects agnostic? So does it depend on a specific database, or does it work with any database supported by Flowable?
This is completely agnostic of the database. Yeah. Technically, we're just storing the ID of the data object and the definition key or definition ID of the data object, so that we can resolve the data object. It doesn't matter which database you are using.
Yes, and similarly, somebody asked whether we have a integration with MongoDB using data objects, or whether it's purely REST API based. I mean, MongoDB is a supported database, right, Roman? So in the end, yeah, two different things,
yes, right? Those are two different things. I mean, you can have your external service that is based on MongoDB, but with REST data objects, you'll have to provide your REST interface to interact with MongoDB. If you're using MongoDB as a Flowable database, that's a completely different question. Yeah.
Okay, yep. I just got word that the integration with forms is also planned for the next release, like further integrations is coming. So that's even better. Okay, then we have a question about web services instead of REST API. That's a tough one. So this is with REST API, probably we are referring to JSON-based ones, right? Yes, whether this is also possible.
Web services, I'm not sure what's
probably
meant here.
SOAP-based, I suppose.
SOAP-based, yeah. Okay. With data objects, well, our integration is mainly based on JSON, but theoretically you could also integrate with an XML-based service. You would have to write your you would have to do your own marshalling and unmarshalling of your request. So you would have to, in your service registry configuration, you would need to parse the XML, convert it in extract, like in your XML response, you would need to extract the data yourself. And when you send a request, you could use a template, an XML template, for example, a free market template where you put in exactly the data that you want before it is sent to the other service. It's not as easy as with JSON, but it's doable.
Very good answer. So somebody asked whether there is a limitation on data object size and number. As long as we're staying reasonable.
There is no, as far as I know, there is no technical limitation.
There may be
you have to know that every
MBs.
time, yeah, I mean, every time you are opening a case or interacting with a case that has data objects, these data objects are retrieved from the other service. So the more data objects you have, the more requests will be done. So at some point, that probably doesn't make any sense anymore. So here I would say the answer here is the classical architecture answer. It depends on how big your data objects are and so on. Depends on how your environment, on your systems, what kind of load your systems can have, and so on. So there is no straight answer here, unfortunately.
Okay, cool. Next one is an easy one again. What about synchronization from the external data sources instead of from Flowable? I think you've answered that during the presentation, right? So external data sources via REST, not a problem, but you can also do it through database.
Yeah. Maybe a good thing here is with this data object, if we change something in the external system, then the next time we are accessing the data object within Flowable Work, you will see the updated data. So it will, when you interact with the data object, it will always retrieve the most recent version of the data object from the external system. So you don't have to update it directly in Flowable, but it will always have the most recent information.
Okay, then we have another one. Do we still have time? I think so, right?
I think so, yeah.
Okay. Exactly. Where one participant would like to know whether there are grouping features such as count and group by on data objects out of the box. Probably referring to the database-based data objects.
Yeah, that's probably more something for database objects. If you're using an external REST data object and you want to have some additional operations, you can always add some more operations here or maybe dear technical team, can you maybe show my screen again?
Yes, go ahead.
Okay, so people can see my screen again.
I don't think so yet. Now it's
good. Okay, great. Thank you very much. So in our data object configuration, we can also add, let me close this here. We can add additional operations. So if your REST API also provides some group by or some other operations, we could also integrate them here and call them there directly with your data object if necessary.
Good. Then another question was whether we do have any caching to improve performance or batching, right?
That's a good question. I am
As you
not
said
sure.
before, by default, it will always fetch to have.
By default, I think if you access the same data object within the same transaction multiple times, there is some caching. But if you have multiple transactions, then it should retrieve the most recent data object from the external system because it might have been changed in the meantime. You can never be sure if it's still the same. So there is some caching I think within one single transaction, yes.
Very good. Then this one is regarding AWS SIG v4 authentication. Do we have support for that with our REST services, AWS SIG v4 authentication?
V4, I'm not familiar with that authentication mechanism.
Yeah, but as you said, if you quickly click on the response head,
I mean,
well, it's not.
I mean, of course, as I've shown you before in the presentation, you can set your own custom headers. So if this authentication mechanism is based on headers, you can inject in there anything that you want. So you can build your own authentication header and use it there. Yeah, you can implement your own Java method that does this. If you have a more complex way of authentication, there's always a Java interface that you can implement in Flowable in the backend, where you have access to the whole request, to the whole service registry request with the headers and the body and everything, the whole request, and you can change it any way you like before it's actually sent. You have the same thing for the response. You can access the response before it's passed to the service registry and modify your data. So in my opinion, any authentication mechanism should be integratable.
Good. Then we have another one regarding REST database, REST data object. Is it possible for data object, data table to use filters and sort with REST like data table? I think this is referring to the UI element.
To the UI, yes, that's possible.
Yeah, with the out of the box one, the REST based one, it says it is not possible at 3.12.2. Yeah, we would need to check.
For the data object table.
Yeah, filtering and sorting. That's the reduced one.
Good question. Very detailed question.
Yeah, we would need to check.
Yeah, we would need to check
if it's currently
yeah, we can we can check this. Yeah.
Yeah, we have your coordinates, so we will get back to you if that helps. Yep. Good. Then another one. You're really bombarded with questions here.
Yeah, that's good. That means that people are interested.
Yeah. Can we maintain hierarchical data objects like parent or child? How that can differentiate in web service calls? So whether we can have any relationships between different data objects, as I understand it. We can have references. Right.
You can, I mean, you can put your ID in your external data object, but I don't think we have this available out of the box for REST data objects. We have some some support for hierarchy for database data
yes,
objects.
This was also in the question. Sorry, yeah. Can we maintain hierarchical data object? Yeah, exactly.
But not for REST so far, as I know.
Yeah. So we can have that. Good. We are almost done. Then one question was whether there is a standard way to sync data objects from external data source, so basically through pushing mechanisms, push event from an external data source, for example. So
I mean, standard. I mean, you can. I would probably do it with Kafka events. So if you have a new data object that you want to create, you can send an event to Kafka, and Flowable will listen to that and then act on that. In all the projects that I've been to, every customer does it slightly different. Everyone has their own preference on how they want to do it. So
it's, as always, it's a combination of different approaches, right? Like some things are there out of the box, but something like this may be so specific to your use case. So I think that answers that. Then there's one more, I think. can I have an external database for database-based data objects? As far as I'm aware, this is not currently a feature.
No, I don't think so. Currently, that's not there out of the box.
Okay.
No, you would need a separate data source. Not with the current implementation, no.
Okay. One more, sorry. And then there are two
Almost there.
organizational ones. Yeah. How does this compare to the use of Elasticsearch and fetching data through the Elasticsearch query language in the process flow?
I mean, in Elasticsearch, you store your data, so it's easily accessible. You can search it very quickly. You can use it for dashboards, for metrics, and so on. But the main source of truth is still the Flowable database. You can, at any point, you can delete everything you have in Elasticsearch and do a reindex, and Elasticsearch will contain the data from Flowable again. So it's a replication of our data in the database. What we do with the REST data object is different, because we don't want to store the business data anymore. We want to store it in a separate system. And for that, we retrieve it whenever we want. A nice feature is, if you have a data object, it's still indexed in Elasticsearch. So you can still search for data in Elasticsearch that is stored in your data objects at the same time.
That's right. Good. And then there are two organizational questions. Whether this workshop is recorded. Yes, as always, we record all the sessions. So you will be able to check that later. And whether we can share this flow. I think we can check whether we can also make this demo application available as well. Okay. If you have any last question, please post it now, because time is running short. Okay, let's wait for another 20 seconds and then. No, I think we're done.
Great. Then thank you everyone for your attention. And I wish you a very interesting following presentation and good rest of the FlowFest. Thank you very much.
Have fun.